Scientific notation. So we're going to use this example. This is a great example to have down in your notebook if you need an example to look back to. Earth is about 1.5 times 10 to the 8th kilometers from the sun, while the planet Neptune is almost 4.5 times 10 to the 9th kilometers from the sun. The distance from Neptune to Earth is about how many times the distance from the sun to the Earth. So as we look at this word problem, I want you to pay really close attention to this phrase. How many times the distance? And think about another situation where you might be thinking about how do I figure out how many times something is compared to something else. Now, we can break these out. All the operations that we're going to learn in scientific notation, you already know how to do with numbers that are broken out like integers. Or you already know how to add integers, subtract, multiply, and divide. So we can break these numbers out into standard form and do all these operations how you already know how. And we will. But what we're also going to do is learn how to do these operations in scientific notation, keeping the numbers in scientific notation so you can see the differences because you may choose to use one over the other. If I broke out 1.5 times 10 to the 8th, what is 1.5 times 10 to the 8th? How would I break that number out? It is, you're right, it's 150 million. Now, if you're not really sure and don't feel as comfortable with your powers of 10, you could always take your 1.5 and represent multiplying by 10 8 times. Just to make sure that you actually are working with 150 million, which we are. How about the number 4.5 times 10 to the 9th? Say again? Yep, it is 4,500,000,000. Perfect. What operation are you doing if you're trying to determine how many times greater 4.5 billion is than 150 million? What operation is that? I hear a few operations, so let me pose it with different numbers. How many times greater is 150 than 50? 3. Because why? I multiply 50 by 3 to get 150. So if I'm doing that in reverse, what is that operation? Yeah, I'm dividing. Now the reason I point that out, so many students will see this question on a real world example and multiply. Even though it doesn't make sense to multiply, unfortunately, if you're programmed to look at a word problem and just pick out the mathematical terms, you might see the word times and automatically assume that's multiplication. But they're not asking you to multiply. They want to know how much bigger is one of the numbers than the other. So we're going to divide. So how would you divide that? What would you do if I said to find how many times greater 4.5 billion is than 150 million? What would you do? Okay. How would you do that? We're going to do the scientific notation one after. We're going to do it all broken out first, and then I'm going to show you how to do it in scientific notation, so you can figure out which way. How would you do that? Now, if I broke this out into a fraction, can I do that? Can I show this as a fraction? Yeah, because we know that fractions represent division. Okay. How do you divide that? If you see that, what do you think to do? How do we divide it? Okay, keep going. What do you mean by that? So one of these, this is a good observation that Ibrahim is noticing, is like they have similar place values there. What do those zeros represent? Like every time I have that other 0, it's another power of 10. So divided both the numerator and the denominator and simplified it by dividing by 10, I would have removed that 0, essentially, by dividing by 10. And then if I divided by another 10, and another 10, another 10, another 10, another 10, and another 10, I've now simplified this fraction. What simplified fraction do I have now? Yeah, I have 450 divided by 15. Could you tell me what 450 divided by 15 is? It is 30. So 4.5 billion is 30 times larger than 150 million. Now that would be breaking it out into standard form. What's a drawback to that? Like, why may that not be the best way to do that problem? Okay, so maybe not easily divisible, right? That we may just have a hard time dividing numbers. What else? Think about how it looked when we first had like the 4.5 billion all broken out and the 150 million all broken out. What else could happen along the way? Place values could definitely get you a little tripped up. Earlier today, we had some students who said when it was all broken out, they said, oh, you can just divide the 45 by the 15. Could you just assume to do that? No. When we simplified it out, it was actually 450 divided by 15. So again, that's another possible problem. Now, we could compare these numbers in scientific notation without breaking them out at all. We keep them in their format here, right? And we can still divide and get the same answer that we had. Now first, let's take a look at the comparison between these numbers here. Right? If I need to know how much larger this number is, how many times larger than this one, let's compare 1.5 and 4.5. How many times larger is 4.5 than 1.5? Yeah, because if I multiply 1.5 times 3, I get 4.5. So I know that it's 3 times larger. Now be very careful here. I know in this example, and looking back, maybe not the example I should have used, because 4.5 minus 3 is also 1.5. We are not subtracting here because we're trying to find out how many times larger we divided to get that number. Now, how do we compare 10 to the 8th and 10 to the 9th? How many times larger, girl stop, is 10 to the 9th than 10 to the 8th? How do you know 10 times? What did you divide? You divided 10 to the 9th and divided by 10 to the 8th. What does that look like? What topic that we've already done does that look like? That's the division property of exponents, right? If I have the same base and I'm dividing, what can I do with my exponents? I can subtract them. 9 minus 8 would be 1. Now, is there another way I could have proven that it's 10? Did I have to do the rule here and subtract? What could I have done? If I really needed to know. Yeah, I could have broken it out and done the 10 times 10 times 10, 4, 5, 6, 7, 8, 9. And then down here, I could have done 8 of them. And then when I found my big ones, I'm left with 10. You could have done that as well. So now let's put it together. We determined that 4.5 is 3 times larger than 1.5, and we know that 10 to the 9th is 10 times larger than 10 to the 8th. So what we just did is divided by keeping these numbers in scientific notation. Notice what we did here. If I divide that down the middle and just break it up, on the right side, what skill is that we have already learned how to do? That's the division property of exponents. And the nice thing is, because these numbers are in scientific notation, your base is always going to be 10. Because when we write a number in scientific notation, it's something times 10 to an exponent. So that's the division property of exponents. And over here on the left, this 4.5 divided by 1.5, that's division. What do you notice about those numbers? Like, think about any type of division problem when you're working with numbers in scientific notation. What do you know about these two numbers? What are they always going to be? Because they're in scientific notation? They're always going to be that first number, right? But what do we know about that number? They're always going to be less than 10, but more than 1. So they're always going to be between 1 and 10. So think about that. Think about dividing. Would you prefer to divide a number between 1 and 10, or would you prefer to divide a number that might be billions and trillions and millions? So if I put this together, 10 to the 9th divided by 10 to the 8th is 10 to the 1st. And 4.5 divided by 1.5 is 3, which that's where we get our 30. So whether you break it out, which you could do if you chose to break it out into standard form and divide, you can. But we went through a few drawbacks to that. Place value can come into play. If we make a mistake in breaking out the number, you could be in trouble from the beginning. But you could also have some issues just dividing in general. If we leave it in scientific notation, we've already done this. We've already been working with properties of exponents. We know how to divide here. Whether we break it out or we just use the rule, you're good. Over here, can you simplify or divide however you need to get a value like 3? Now, the issue becomes which number is dividing by which number. If you're working with a word problem, that tends to be the tricky part. So you have to ask yourself, which number is being broken up? Which number is doing the dividing? Right? So that matters when you get these real world problems. We're going to go over some examples so you can see what I mean by that. You're going to try one and we're going to work together. And you're going to do it both ways. So I'd like for you to try 4.8 times 10 to the 7th and 1.6 times 10 to the 4th. So I would like for you to show how many times greater 4.8 times 10 to the 7th is compared to 1.6 times 10 to the 4th. You're going to do this two ways. I would like for you to break it out in standard form. And then I'd also like for you to do it with the numbers still in scientific notation. The order does not matter. But as you're working, and you can work with the people around you, I want you to have a conversation about which method you prefer, which method makes more sense at this moment. Are there ever times where one would be better than the other? Are there other times where the other one might be better? Think about what could happen with these numbers in scientific notation that may make it a little trickier. We're going to go through a few examples afterwards that have some little hiccups that we have to figure out. It'll take about 5 minutes. Now I want you to try to break them out both ways. Now I'm probably going to pause the video while you do this. Actually, no, I'll keep the video on so that we can go through the example and that's up. You may find as you're going through that one way is a little bit more straightforward for you than another. Don't think that because it's new that the scientific notation version is worse, right? Just deal with that struggle for now because there's How many times, what would you multiply 1.6 by to get 4.8? How many times does it go into the 4.8? Good. Okay, let's take a look. First, we'll break this out into standard form. What is 4.8 times 10 to the 7th? What number? And what is 1.6 times 10 to the 4th? For those of you that simplified this and divided it in standard form, that's what you do. So if you first simplify by dividing out 1,000, these zeros would pretty much eliminate from your fraction. I divide out the 1,000. I'm actually left with 48,000 divided by 16. Now what?
Now,
Divide them.
yeah,
I can divide them. What do I know?
that's a factor of.
You're saying it, and I heard you say it too.
Factor of, like 48, and that divides me.
48 and 16. 48 is divisible by 16. Right? How many? What is that divisible by?
3.
3. So if 48 divided by 16 is 3, then 48,000 divided by 16 must be
3,000.
3,000. So I'm even going to do these in a different color to kind of show you where this all comes from in the scientific notation division. If I divide this in scientific notation, what do I got?
Oh, 3 times.
Right, let's start on the left side first. 4.8 divided by 1.6 is 3. 10 to the 7th divided by 10 to the 4th is 10. I heard you say to the back to the 3rd. Now, the 3 was here. You divided the 48 by the 16. And then the 10 to the 3rd represents that 1,000. So 3 times 10 to the 3rd is also 3,000. If you left it as 3 times 10 to the 3rd, you're good. So now we're going to step it up a notch, just a little bit. I have a specific reason why the next two are on the page. So as you're going through these, I want you to work together because they're a little tricky, but I want you to think, why would I put these two problems up now? Where's the focus for each question? So the first one, 6 times 10 to the negative 5th, is how many times the value of 3 times 10 to the negative 8. The second question, star A, is about 3.4 times 10 to the 18th miles from Earth. Star B is 6.8 times 10 to the 16th miles from Earth. Star A is how many times as far from Earth as star B. So I'm going to add 6 minutes up here. Okay? But think specifically as you're going through these, why these, why now? I am going to pause the video here while you work.